Lost foam casting is a casting process that uses raw material EPS or STMMA, FD to produce white models that are similar in size and structure to the castings, including shrinkage. After being coated with refractory bonding coating to strengthen and smooth the surface, the models are dried and buried in a special dry sand mold. The mold is then vibrated in 3 dimensions and subjected to negative pressure to pour in molten metal, forming the casting. The entire casting process is a one-time forming process under a certain negative pressure, where the foam model is heated and decomposed, and then replaced by molten metal alloy. The process of lost foam casting is traditionally divided into 2 parts, the white area and the black area. The white area refers to the process of making the white foam model, including pre-foaming, maturing, molding, bonding, coating, and drying. The black area refers to the process of putting the model into the sand mold, filling the sand, melting the metal, casting, regenerating the old sand, cleaning the casting, and annealing. To give everyone a clear understanding of the process of the lost foam white area, the following is an introduction to the process flow of the lost foam technology white area. First, flow chart of lost foam white area production. In order to give you a clear understanding of the white zone process of EP process, we introduce as follows. First, the 3 conditions of steam, water and compressed air are met, EPS raw materials are pre-expanded, the expanded beads are matured. The matured beads are injected into the mold of the molding machine for molding, the molded foam white mold is dried and coated, and the qualified yellow mold is pushed into the black area for casting. Second, description of lost foam white area production. Firstly, EPS or STMMA raw materials are expanded, and then the qualified bead particles transported to the shape molding machine or block machine through the bead particle conveying pipeline. Secondly, the foam white model produced by the shape molding machine is first dried in the white model drying room for preliminary dehydration. Then, the preliminarily dried model is bonded for assembly, and the bonded model is coated with the first coat and dried. After that, it is transported to coat and dry for the second or third time. After drying, a qualified finished model can be obtained. The model is then ready for casting. The above is the overall process of the lost foam white area. Now, the specific processes and precautions of each stage will be introduced. First, raw material selection. The white area of the lost foam casting process is to make foam patterns. First, suitable materials must be chosen. There are 2 types of materials commonly used in the lost foam casting process: expandable polystyrene EPS beads and expandable styrene methyl methacrylate STMMA copolymer beads. EPS is the most commonly used material for lost foam casting due to its easy processing and low cost. It is often used to produce non-ferrous metals, gray cast iron, and ordinary carbon steel parts. Copolymer beads are suitable for casting steel parts and nodular iron parts, and can achieve better gasification effects. Different products require different materials. After selecting the appropriate beads, pre-expansion should be carried out during the pattern making process. Second, pre-expansion. Let us introduce the commonly used EPS beads. EPS beads need to be pre-expanded before they are put into the mold so that they can expand to a certain size. The task of the pre-expander is to heat the raw materials containing a certain amount of foaming agent, so that the beads soften and expand to a certain diameter or reach a certain bulk density, while retaining a certain amount of foaming agent. The pre-expansion process determines the density, size stability, and accuracy of the model, and is one of the key steps. Our company produces pre-expansion equipment suitable for EPS beads, mainly including steam heating pre-expander, which uses the most advanced PLC technology. It mainly uses steam to penetrate and heat the beads during pre-expansion, making the fully foamed particles and air more elastic and adhesive after maturation. The pre-expanded beads are detected by a vibration sensor for material level and automatically detected by a density detection system. The steam pre-expander has high foam production, low downtime, and improved production efficiency. According to the local environmental protection requirements, a set of photocatalytic activated carbon purification equipment can be installed on the pre-expander machine, and the exhaust gas during expansion can be discharged outside the workshop to meet environmental protection requirements. Third, EPS beads maturation. Place the pre-foamed foam beads in a dry and ventilated silo for a certain period of time to allow air penetrates into the interior of EPS beads to balance their internal and external pressure and stabilize the EPS beads, making the beads elastic and able to expand again. At the same time, remove the moisture on the surface of the beads. The beads are transported to the maturation silo through an automatic conveying system, and the maturation time is generally controlled between 8 to 48 hours. Fourth, shape molding. Fill the pre-expanded and matured EPS beads into the cavity of the mold, and then inject steam to heat the beads, soften and expand them again, fill the gaps between the beads, and make the beads fuse with each other to form a smooth surface. The model must be cooled before it is demolded, and the temperature of the model must be lowered below the softening temperature. After the model is hardened and formed, it can be demolded. After demolding, the model should be dried and stabilized in size. Our company's Lost Foam shape molding equipment mainly includes vacuum energy-saving hydraulic molding machine, top material filling automatic hydraulic shape molding machine, PLC-controlled hydraulic shape molding machine, PLC-controlled screw shape molding machine, and Lost Foam block molding machine. Considering that there are currently many varieties and quantities of casting products, in order to save production costs, big blocks can be molded with the block molding machine and then cut into shape. The white foam model may encounter various problems. Now we will introduce several common problems and solutions. First, the continuity and adhesion of the inside and outside of the white model are not good. The reason is that the heating pressure is not enough, or the heating times are not enough. The solution is to correct it by adjusting the contact point pressure gauge, heating times, and main heating. Second, the surface of the model appears chicken skin phenomenon. The reason is that the water cooling time is not enough, or the heating times are too many. Third, there are two factors for model deformation. One is that the air plug is blocked, and the demolding part encounters difficulties. The other is that the cooling speed of the model is inconsistent, resulting in one side of the white model stopping molding, while the other side continues to mold. Fourth, during the demolding process, the white model always has fine pull marks, but the forming quality is good. The reason is that the blowing air pressure is too high or the time is too long. The main adjustment is the time parameter. Fifth, drying. After shape molding, the white model needs to be dried before use because it is damp on the surface and contains a small amount of moisture inside due to steam heating and water cooling. The white model is placed in a drying room for drying, and a temperature and humidity control system is used to automatically regulate and control the temperature and humidity inside the drying room, while using hot air circulation to dry the white model products. Our company produces two types of drying room heating system: energy-saving air energy drying system and steam and electric heating dual-use automatic circulating heating system. The energy-saving air energy drying system uses air energy heating, and the heat source is absorbed from the air by the compressor of the air energy host and converted into hot air, which is blown into the drying room by the air supply fan through the white iron pipe square tube on the top of the drying room. The hot air is then sucked back into the host through the lower air duct and used for heating again, reducing the consumption of heat source and achieving the effect of energy saving and cost reduction. There are 4 fans on the top of the drying room to stir the air to ensure uniform temperature throughout the room. In addition, there are 5 monitoring thermocouples placed at 4 corners and in the middle part of the room to monitor the uniformity of temperature in the whole room. The front wall of the drying room is equipped with a PLC computer control system to monitor the drying status of the drying room. The temperature of the drying room is always maintained at around 35 degrees Celsius to 55 degrees Celsius during normal operation, and the humidity is maintained at around 15% RH. Because the air energy drying room has a large dehumidification capacity, the drying speed is faster, reducing the drying cost, which is only 1/3 of the cost of steam and electric drying. The temperature and humidity of the steam and electric heating dual-use automatic circulating heating system are usually set at a temperature of 45 degrees Celsius to 55 degrees Celsius with a hysteresis of 5 degrees Celsius, and a humidity of 15% RH with a hysteresis of 3% RH. If the temperature is too high, the white model may deform and the coating may crack. If the temperature is too low, the drying may be uneven, affecting the drying effect. The heating methods of the drying room include steam heating, electric heating, or steam and electric dual-use heating. Sixth, foam model bonding. In order to achieve ideal model effects and smooth casting channels, we usually combine multiple white models together. Foam model bonding is an essential process in lost foam casting, which mainly uses hot and cold glue to bond. Bonding methods can be done manually or with an automatic bonding machine. The use of stick glue and stick glue gun are used together. Insert the stick glue into the glue gun and adjust the gun hole to 130 to 160 degrees. Directly apply the glue to the model components, quickly position and press the other component on top, and achieve high-strength bonding shortly after. During the bonding process, the glue should not be excessive, and the principle is to bond well. Too much glue will cause too many air holes in the casting. The glue should not be too thick to avoid dimensional inaccuracies. The bonding seam should be filled with glue as much as possible, and there should be no unbonded seams to avoid coating entering and causing casting defects. The glue outside the bonding seam should be scraped off to ensure the smoothness of the model surface. After bonding, check the bonding seam and model surface, verify the dimensions of each part, and use beauty paper to fill in if necessary. The equipment commonly used for foam model bonding includes cutting platforms, bonding platforms, and automatic bonding machines. The automatic bonding machine is easy to operate, highly automated, fast, and labor-saving. The automatic hot glue machine consists of 6 parts: the machine frame, mold frame, glue tank, vacuum system, hydraulic system, and PLC control system. The upper mold frame moves along the guide rail to the top of the glue tank, and the glue plate moves up to apply glue to the mold pieces attached to the upper mold frame. Then, the upper mold frame moves along the guide rail to the top of the lower mold frame, and the cylinder pushes the lower mold frame up so that the mold pieces of the lower mold frame and the upper mold frame are joined and bonded. After bonding is complete, the upper mold frame flips outward and can be manually removed. 7th. Foam model coating. Coating is an essential part of the lost foam casting process. Its main function is to increase the strength and rigidity of the model, prevent cracking or deformation, isolate the metal liquid and the column, remove the gasification products of the model, and ensure the surface quality of the casting. The coating for lost foam casting requires good strength, permeability, fire resistance, coating properties, suspension, and one-time shedding, etc. to reduce casting defects such as porosity and sand sticking, and ensure the yield of castings. Before coating, the coating material needs to be mixed with a certain amount of water and stirred evenly using a coating mixer. Our company produces lifting-type coating mixers. The main function of the coating mixer is to uniformly stir the coating material at a constant speed to achieve sufficient mixing, homogenization, dispersion, and accelerated dissolution and prevent the coating material from settling. Put the white model into the stirred coating material for coating. The immersion layer should be even, and the excess coating material should be removed by shaking in time after immersion to make the coating even. Transport the yellow model after the first coating with a small cart to the drying room for drying. To obtain a uniform coating thickness, a second or third coating and drying can be applied. After drying, a qualified finished model can be obtained. Then the white area in the lost foam casting process is finished. Here is a brief introduction to the lost foam casting black area process. The EPS model with dried coating is placed in the sandbox and compacted, and then sand is added and fixed according to the process requirements. The dry sand is dynamically flowed in the sandbox through the vibration table to improve the compactness and density of the dry sand, and to prevent casting defects. The casting line consists of a molding line and a return box line. The cyclic operation of the sandbox is completed by the sandbox track shuttle transfer vehicle. Each production line is composed of a certain number of sandboxes according to the process requirements, and the molding line consists of 3-dimensional vibration tables. The molded sandboxes enter the pouring and cooling line in sequence, which is composed of vacuum docking machines. After a certain number of sandboxes enter the pouring and cooling line, the vacuum docking machine automatically docks and uses manual and mechanical pouring. After pouring, pressure is applied and cooled, and then the vacuum docking machine is reset, vacuum is withdrawn, and cooling is carried out. While the 2 pouring lines are pouring, the molded sandboxes on the molding line enter another pouring line to wait for pouring and repeat the actions of the pouring line in a loop. During pouring, the EPS model is gasified under the thermal effect of the liquid foundation, and finally forms a casting with the same shape and size as the model. Compared with traditional casting techniques, lost foam casting has unparalleled advantages. First, good casting quality and low scrap rate. Second, improved dimensional accuracy of castings. Third, smooth surface and reduced cleaning. Fourth, strong adaptability to casting materials. Fifth, reduced internal defects and dense structure. Sixth, automated production for green environmental protection. Seventh, saved processing time and improved production efficiency. Eighth, reduced labor intensity and energy consumption. Ninth, easy mastery of the technology and improved working environment. 10. Low investment and quick results. Our company adheres to the concept of professional manufacturing and honest operation, providing practical layout solutions for customers' lost foam workshops. During the installation process, we arrange technical personnel to guide on-site installation and debugging of equipment until qualified foam white models are produced. We also provide customers with lifetime free technical consultation services during their production process.